Alright, this is problem 56 of the final review, and we are using, it says, use the indicated point coordinates to find the equation of the line. So, the equation of the line, of course, is our equation of y equals mx plus b. And when they say find the equations, what we have to find is slope and the y-intercept, because m is the slope and b is the y-intercept. The y-intercept is where the line crosses the y-axis. And when I say the line, what I mean is the line that's represented by the equation that we are going to find. And in case we have a picture, in this case, we have the line right here. So where this line crosses the y-axis, and this is the y-axis, this is the x-axis, and that point where this line crosses is right there, and that is point 0, 2. So the actual point itself is 0, 2. And the y-intercept is supposed to always have a 0 value for x, because remember, coordinates are built of x and y. So this is the actual point, 0, 2. But how we plug it into our equation is we just use the 2 for b. So b now equals 2. We can plug that into our equation. So we're building our equation y equals mx plus, now we have the b, which is 2. We do not have to find values for x or y. X and y represent any point on the line. Okay, so how to find the slope next? Well, it's a very clever way that we can find it. Yes, you can use this equation, the slope equation between 2 points. And we do a whole problem with this. Using the 2 points given in the picture, so that would be this point of 0, 2, and this point of 2, 0, the other point being 2, 0. And you can find the slope using those 2 points. You can also use rise over run, since we have a nice clean picture, because you have 2 points on the line. So between 2 points, what you do is you build this triangle. Let's use a different color altogether. We have to go down until we get even with this other point, and then we go over to meet the point. And that would give us a negative 2, because I went down 2, because the rise is in the vertical direction, up or down. So from this point, I went down so I can get to the next point. So it's negative 2 over, and the run is in the horizontal direction, either direction. We went to the right, so that's the positive direction. So it's negative 2 over 2. And that's a slope of negative 1. And that's consistent. We have a negative slope and we have a negative picture. When we're walking along, this goes down. This line goes down. So that's a negative slope. Alright, so what we now have is an m value right there. So we can write our equation once again, y equals, now we plug in our negative 1, x plus 2. And that gives us a linear equation. We don't need to fill in x and y values. Those represent every point on the line. This can also be rewritten as y equals negative x plus 2. You don't have to write the 1. It's an option. I think it's just better because it keeps it cleaner and better understood. And what I mean by x and y values can be any point. this is, now that we have an equation for the line, we can now plug in values to get points. So we could say if x were -1, then we plug in -1 for x. We multiply it by this -1, we get a +1. Then we add 1 to 2, and we have 3. And that gives us a point on the line. And as if you can see this, we go -1 and then up 3. 1, 2, 3. And look at that. I'm right on the line. We can do that with any number that we want. If we chose 5, we would have 5 plugged in for x times the -1, which is -5, plus 2, which is a -3. So in this case, we're going to go 1, 2, 3, 4, 5 for x, down -3. 1, 2, 3, and bam, I ended up on the line. Okay, because these x, y values are coordinates. They represent a point on the line. So when you plug in values for x and y, you're churning out points for this line. And that's the point of the linear equation, so to speak. All right, so that's that.